Today I'm going to be dealing with sum and product of roots quadratic equations. So previously we reviewed that the values of x, for example, as roots of a quadratic equation are given by, let's use here the quadratic formula mostly, and therefore we found out that if we have x which was equals to negative b plus or minus root of b squared minus 4ac divided by 2a. So when we derive the quadratic formula, this is what we found. So now let's find out, like, if we get the sum and the product of the roots, what would they present? So you find that we know that x1 in this case would be equals to negative b plus root of b squared minus 4ac all over 2a. At the same time, another root of this, let's say an equation, because a quadratic equation normally has two roots, and therefore we would have here, this would be negative b minus root of b squared minus 4ac divided by 2a. And therefore these are the roots of the quadratic equation. So let's try to get the sum first. Now, with the sum of roots, you find that in this case, if let's like my x1, for example, x1 is given by negative b plus root of b squared minus 4ac divided by 2a, and x2 is given by negative b minus have b squared minus 4ac divided by 2a. And therefore the sum of these roots, therefore I'm going to have here, this would be x1 plus x2, this would be equals to, I'd have negative b plus root of b squared minus 4ac divided by 2a, plus this, and I would have here, this would be negative b minus root of b squared minus 4ac divided by 2a. So out of that, you find that since they have the same denominator, so I can add the numerator. So I'll come here and say that this is negative b plus root of b squared minus 4ac. Yes, there's an addition sign here. So, and then plus, I'm going to have negative b minus root of b squared minus 4ac, but the whole of this is divided by 2a, and therefore I'm going to have something here. So you find that this will cancel with this, and then I'll have negative 2b all over 2a, and therefore I'll have this equals to negative b all over a in this case, and therefore the sum of roots lead us to negative b out of a. As you remember the general format of a quadratic equation, so we know what b is and a is. Now let's go on to the product of the roots. Now the product of the roots, that means that x1 times x2 in this case would be equals to, I'll have here negative b plus root of b squared minus 4ac divided by 2a, close this, and this is being multiplied by negative b minus root of b squared minus 4ac divided by 2a, close this. So when we do a multiplication here, a quick multiplication, we know that we are going to get here, this is going to be negative b plus root of b squared minus 4ac, close this, and we have here, this is negative b minus root of b squared minus 4ac, close this, but all over this is going to be 4a squared. So having done so, the next thing here that I'm going to do is I'm going to say this is going to be equals to, now if you look at the upper operation, this is the same as someone having an operation of this kind, that if you're having this, you find that if I was having a squared minus b squared, this would still lead me to a plus b, close this. This would be a minus b. So if you look at this, I have b and this, and the same case, but the signs are the only ones, that are changing. So this is the difference of two squares. So when I'm working out this, that's the principle that I'm going to be taking in this case. So that when I come here, I'm going to have something of this kind. So this is going to be equals to negative b square this, yes, minus, I'm going to have, this is the root of, I'm going to have b squared minus 4ac, close this, and it is also squared all over 4a squared. So having done so, I'm going to have something which is going to be, I'm going to have b squared minus, remember this, the squared will cancel with this, and therefore we are going to have here minus b squared plus 4ac divided by 4a, and therefore this is going with this, and therefore in this case we are going to have something that's going to be 4ac divided by 4a, and therefore this is squared, this is also squared, and therefore we are going to remain with something that's going to be c all over a, and therefore the product of the roots will lead us here. So now let's try to apply this in some cases, like to find the kind of quadratic equation when you've been given the nature of the roots, for example. Now we know that a quadratic equation exists in this format, that I'm having ax squared plus bx plus c is equals to 0, but you find that b and c have their own meanings. So b exists as the sum of roots, and c exists as a product of roots in this case. And therefore you find that if you write it in terms of this, you find that I'm going to have a x squared minus, because this one is initially negative, but maybe when you insert something there, that's fine. But when we are expressing it in terms of sum of roots and product of roots, this one is negative. So in the bracket, sum of roots, and we put an x outside, then plus the product of roots, and therefore this is equals to 0. So you find that when you're working out, this is how, for example, if you've been given certain roots and you're told to find this the quadratic equation with such roots, and therefore these are the steps that we take. So for example, if I've been given a question of this kind, x squared minus 5x minus 7 is equals to 0, and I've been told find equation whose roots are 1 all over alpha and 1 all over beta. So we are going to come from the first principles, let's say from the beginning to the end, to work out this problem. So you find that you've been given a quadratic equation that's complete, and then you've been told to find another equation with roots of 1 out of alpha and 1 out of beta. So you find that to work out this, the major principle here that we follow is that if I'm to use, for example, we found out that sum of roots would be equals to negative b out of a. And therefore, we know that here, this equation is in form of ax squared plus bx plus c, which is equals to 0. And therefore, in that case, I know that I can get my b, and therefore b is negative 5. So when it meets this negative, it becomes positive, and therefore my a is 1, so all over 1. And therefore, I'm having 5 as my sum of roots. Now, let's look at the product of roots. So product of roots, in this case, we found out that the product of the roots was c all over a, and therefore in this case our c is negative 7 and our a is 1, and therefore I'm going to have negative 7, yes, negative 7 as my product of the roots. And therefore, when I'm working on this, so I come here and say that now if the sum of the roots is giving me 5 and the product of the roots is equals to negative 7, so what if I add this, I get the sum of the roots, like 1 out of alpha and 1 out of beta? At the same time, I get the product of the roots of 1 out of alpha and 1 out of beta. Now, let's try to work out. Now, let's try, if I say sum of roots, I know this is going to be 1 out of alpha plus 1 out of beta. Then I know that if I work out this, this is going to be beta plus alpha all over alpha beta, which will be, we know that the sum of the roots is 5, and the product of the roots alpha beta is negative 7, and therefore this is going to be negative 5 out of 7 in this case. So we know that sum, let me write it here, sum is equals to negative 5 out of 7. Now let's try to find for the product of the roots. For the product of roots, we know that this would be equals to, I'm going to have 1 out of alpha times 1 out of beta, of which in this case I'm going to have 1 out of alpha beta, which would be equals to, as we obtained recently, was negative 7, and therefore I'm going to have here negative 7, and therefore this is going to be negative 1 out of 7. Now, having worked out that, now to form a quadratic equation, I'm going to come back with my recent, for example, expression. I'm going to say that x squared minus sum of roots, close this, x plus the product itself would be equals to 0. And therefore, when I come here, I know that x squared, for example, minus, now the sum of the roots that I obtained recently was negative 5 out of 7, x plus the product, which is negative 1 out of 7, equals to 0. So you find that if I make this to be a general equation, I know that this is going to be 7x squared plus 5x minus 1, and this would be equals to 0. And therefore, this is my general quadratic equation that I've derived from a different quadratic equation, but using sum and product of the roots. Let's try to use the sum and product of roots to evaluate expressions, for example. Now, the famous expressions that you should be keeping in mind here that we are going to mostly use, we are going to have, for example, if I alpha squared plus beta squared, this would be equals to alpha plus beta squared minus 2 alpha beta. Now, if I have, for example, alpha cubed plus beta cubed, this would be equals to alpha plus beta cubed minus 3 alpha plus beta. Now if I have, for example, alpha squared minus beta squared, this would be equals to alpha plus beta plus beta. This would be squared minus 4 alpha beta. And therefore, when we are working out, these are the expressions that we are going to be mostly basing on. Therefore, let's try out with one example. Suppose I have an equation, in this case, of 3x squared minus 5x plus 1. This is equals to 0. And I've been told like to evaluate, for example, Roman 1, alpha squared all over beta plus beta squared all over alpha. So let me not write it like this, and so all over alpha squared. So out of that, when I'm working out this, what I'm going to do first, I'm going to get the sum of roots, sum of roots of which would be equals to negative b all over a, in this case giving me a 5 out of 3, and then the product of roots giving me I'm having c, which is 1 out of 3. Now having obtained those, now let me write them somewhere. I'm having my sum equals to 5 out of 3, the product being 1 out of 3. Now let me remove this because I don't need it, and this. Now having found the sum and the product, the next thing here is to use now my expression to evaluate it. Then I know that alpha squared plus beta squared, this is all over alpha, this is all over beta, this would be equals to, I'm going to have alpha cubed plus beta cubed all over alpha beta. And therefore I'm going to have, I know that for the above expression, I know that I'm going to have alpha plus beta, this would be cubed minus 3 alpha beta into alpha plus beta, close this, all over alpha beta. And therefore I know that this, like, the sum of roots is 5 over 3, so I'm going to have 5 out of 3, close this, cubed, minus, I'm having 3 into product 1 out of 3, close this, and then the sum of roots 5 out of 3, but remember the whole of this is divided by the product, therefore 1 out of 3. And therefore if I continue with my working, you know that this is going to be 5 cubed, 5 cubed, I'd have 1 to 5, this would be 1 to 5, I'm going to have 1 to 5, in this case all over 27, minus, so this 3 will cancel with the 3, and therefore I'll have minus 1 times 5 out of 3 all over, this is all over 1 out of 3, of which I'm going to have 1 to 5 out of 27 minus 5 out of 3, but the whole of this is multiplied by 3, and therefore I'm going to have, this is going to be all over 27, of which this is 125 minus 27 divided by 3. I'm going to get 9. So 9 times 5, which would be 45. But the whole of this times 3, of which by 3 1, by 3 9. And therefore the next thing I would get here, I would get, for example, 125 minus 45, and this would be 80 all over 9. And therefore this is how we have evaluated this expression, and the final answer for this is 80 out of 90. And therefore this, for example, if another expression has been given, for example, if I have my Roman 2 here, that I'm having 1 out of beta cubed plus 1 out of alpha cubed. Now let's try to work out this expression still. Having known that we still have the same sum and the product, so what we're going to do here, we're going to say that 1 out of beta cubed plus 1 out of alpha cubed, this would be equals to, I'm going to have alpha cubed plus beta cubed all over alpha beta cubed. And therefore this would be equals to alpha plus beta cubed minus 3 alpha beta into alpha plus beta all over alpha beta cubed. And therefore I'm going to have something that's going to be, now let's let me move this to we know that, for example, the sum of the roots is 5 out of 3. So we are going to have 5. We're going to have 5 out of 3, but this is going to be cubed minus 3 into what is alpha and beta. So let's say the product, we are going to have 1 out of 3, close this, and then into, again, the sum of the roots, we are going to have 5 all over 3, then all over. Now the product of the roots, we are having 1 out of 3, but in this case it is cubed. So when we extend it this side, we are going to come here and say that this is equals to, and have equals to, this is going to be 1 to 5. So 1 to 5 is divided by, this is going to be 27 minus, this 3 will cancel with this 3, and therefore, so I had 3 to this and that, therefore I'm going to have, this is going to cancel with this, having cancelled, so I'm having minus 5 out of 3. So the whole of this is multiplied by times 27. So out of that, I'm going to come here and say that this is going to be we are having 27 as our LCM, and I'm having 1 to 5 minus, of which dividing this I'm going to get 45 still, close this and multiply times 27, and therefore this would be equals to, cancel this with this, so we are going to have almost 80 around here. So we find out of that, this is the answer for our expression. So we got this and this. So this is how we evaluate expressions using sum and product of quadratic equations. The main basis here is knowing the quadratic formula, and then from there you can work out, for example, such examples. Thank you for watching. Don't forget to subscribe. If you like the video, give it a thumbs up, and don't forget to comment, and see you next time.